Version 16 has greatly expanded the amount of interaction you can have with a graph. In this demo, I'll be demonstrating some of the important operations that you can do. The first thing we'll demonstrate is rotation of a three-dimensional graph. In version 16, there are now two ways to do this. You can either use the scroll bars at the edges of the graphics window, or you can press the Smooth Rotate button on the Analysis toolbar. To demonstrate the 3D rotations, I've selected a file called 93 cars. This is a file we use to demonstrate a lot of statistical concepts. It consists of information about 93 different makes and models of automobiles. Here I've created what's called an XYZ plot, where I've plotted the miles per gallon in highway driving on the vertical axis versus the horsepower and weight of the automobiles. The easiest way in version 16 to rotate this plot is to take your mouse and grab one of the scroll bars. The scroll bar on the right will rotate the plot in the vertical direction, giving you a different viewpoint. The scroll bar along the horizontal direction will rotate it in the other direction. By properly rotating the plot, you can see that there's actually a fairly strong correlation between miles per gallon and the two predictors, horsepower and weight. To let the plot rotate continuously, I can go up to the Analysis toolbar and press the button labeled Smooth Rotate. In the case of a three-dimensional plot, this brings up a floating dialog bar, and if I push on one of the yellow buttons with the arrows, the plot will start to rotate around it continuously. Notice I've also checked the Draw Text button to be certain that the text will also be drawn as the plot rotates. You need to try this one yourself to get the full effect, because it's much smoother when you do it than it appears to be in this video. One of the most exciting new features in version 16 is what we've called the Response Surface Explorer. What this does is lets you take a model that's been fit, either in the General Linear Models procedure or the Design of Experiments section, and see the effect on the fitted response surfaces as you change one or more of the factors. To illustrate the Response Surface Explorer, I've taken the results of an experiment involving 5 factors: catalyst, temperature, feed rate, agitation, and concentration. And I've created a response surface plot for reacted. That was one of the responses in the experiment. Here, the height of the surface and also the color represents the percent reacted. Dark blue would be very low, dark red would be very high. Now, the dialog box in the upper left will allow me to change some of the factors that have been held constant. With the plot right now, you can see very well the effect of temperature and catalyst, but you can't very well see the effect of the other factors. However, I'm going to take my mouse and grab one of the slider bars on the dialog box. Initially, I'm going to grab feed rate and start changing its value. What you can see as I change feed rate is that the surface moves up and down a little bit, but not a whole lot. If I grab the slider for agitation and change it over its range, it has even less impact on the response. However, if I grab the slider for concentration and change it, you see a much more dramatic impact. And the impact is much greater in the back where the temperature is high than in the front where the temperature is low. That's because there's a very strong interaction between concentration and temperature. There's also an Ascend button on the dialog box, which would ask that little square that's currently at the center of the experimental design to follow the path of steepest ascent. What you'd see if you did this yourself is that the square would start to move, and follow the path of steepest descent, eventually getting up to the maximum value for reactive. Unfortunately, the Adobe Captivate software we're using here doesn't show that very well, but you should give it a try. Another new feature in version 16 is a pan and zoom feature. When you have a lot of data, it can sometimes be difficult to see the details in a graph. Well, the pan and zoom facility allows you to expand either the horizontal or vertical axis and pan back and forth so you can see large amounts of data better. What I'm showing here is a control chart that was generated for data sampled once a minute throughout an entire day. There are 1,440 points on this graph, and it's rather difficult to see exactly what's going on. Now, if I go up to the toolbar, the analysis toolbar, you'll see a button labeled pan or zoom. If I click that button, a floating dialog box will come up. On this dialog box, I can take one of the slider bars and expand the graph in a particular direction. Notice in this case I'm grabbing the slider for time and expanding it so I can better see detail along the x-axis. I can also go down and you'll see a scroll bar along the bottom of the graphics window. If I grab that, I can now pan back and forth throughout the day. Very handy facility when you have a large amount of data. Another handy addition to version 16 is the ability to change interactively the width of a smoothing window when you're smoothing a scatter plot. Here I've created a scatter plot matrix using 6 of the fields in my 93 cars file. If I wish to smooth the various scatter plots, I could go to the Smooth Rotate button on the Analysis toolbar and bring up the options where I can select the type of smoothing and the smoothing fraction that I wish to use. If I click on Robust Lowest, it'll actually put a smooth line through each of the scatter plots in this scatter plot matrix. If I then grab the slider bar near the bottom of the dialog box, I can change the smoothing fraction. The smoothing fraction is basically the percentage of the data that's used every time it smooths a point on that plot. If I make it too small, I'll get too much detail, but if I make it too large, I'll probably over smooth. Using this facility, I can interactively pick a good smoothing constant that gives me the amount of detail that best illustrates what's happening in my data set. Another very interesting technique for exploring data, particularly useful on a matrix plot, is something called brushing. When you brush a scatter plot in Statgraphics, you color code the points on the scatter plot according to the value of an additional quantitative variable. Here's the same plot I showed before, a scatter plot matrix involving 6 variables from my car data file. I have variables like miles per gallon, engine size, horsepower, length, wheelbase, and width, all of which are actually fairly strongly correlated with one another. Now, suppose I had another variable, perhaps the price of the automobiles, and I wanted to know how price was correlated with these other factors. If I go to the Analysis toolbar and push the button that looks like a paintbrush, I can bring up a dialog box. This dialog box lets me pick a variable such as the middle price of a particular make and model of automobile. And when I press OK, we'll then bring up a brushing dialog box. Now, the way this works is right now all the points are colored red because they're all between $7.4 thousands of dollars and $61.9 thousands of dollars. However, if I grab the slider bar and start to move it, it will change the lower limit of the points that are colored red. And the more I change that, the more you'll see that the higher priced automobiles, the ones that are still colored red, are those that tend to get poor miles per gallon. Why? Well, because they're high horsepower, they're long, they have a large wheelbase, and they're wide. And in fact, you can see very strongly the relationship between price and these other variables as you move that slider. If you have a lot of data, and the data is either fairly discrete or heavily rounded, it's common for points to plot directly on top of one another so that you can't see all of your data. Statisticians have developed a technique called jittering, which adds a little bit of a random offset to points in order to avoid the effects of overplotting. In version 16, we've added the ability to dynamically change the amount of jitter in a scatterplot. It can be very useful. For example, here you see a plot, again for my automobile data, where I've plotted the miles per gallon in highway driving on the y-axis and the type of drivetrain on the x-axis. Now, there are only 3 different types of drivetrain, and miles per gallon is measured to the nearest integer, so there's a lot of overplotting. To add jitter to the plot, I'll go to the analysis toolbar and press the button that has 4 arrows. This will bring up a floating dialog box, and I can now grab the slider labeled horizontal and start to increase the amount of jitter in the plot. In fact, I can increase it probably where points start to overlap one another, but if I set it carefully, I can get just the right amount of jitter so that you can see all of the data points. A feature that we added to version 16, because a lot of users requested it, was the ability to interactively label points on a graph, and label them in such a way that if the graph rescaled, the labels would stick with the points. In this graph, you'll see a plot of the miles per gallon in highway driving for my automobiles, plotted versus horsepower. I've gone ahead and fit a reciprocal X model to the data. You can see the line of best fit, curve of best fit, and you can also see 95% prediction limits around that curve. Now, there are a few automobiles that appear to be somewhat different than the rest. In fact, one at least is well outside the prediction limits. To identify those points, I'm going to go up to the analysis toolbar and press the Identify button. This will let me select any column from my data file to identify the points by. I'm going to pick Model and use that. Now I can ask the program to do one of various things. First, I could press the radio button, click Point to Label, in which case it will put a label next to any point if I click on it. I could ask it to label just the unusual points. That's mostly designed for things like control charts where you might want to automatically label points beyond the 3 sigma limits. Or I could ask it to label all the points, although that gets pretty crowded most of the time. I'll stick with click points to label and press OK. Now what will happen is if I go up to an interesting point like this one and click with the left mouse button, it will tell me that, aha, that's a Civic. A Civic, for whatever reason, gets more miles per gallon than you would expect, even given the size of its engine. This point over here is a 626. This point down here is an Aerostar, and this point here is a Eurovan. Very handy ability. The one last dynamic capability I want to show is the ability to remove a point from a statistical analysis simply by clicking on it with a mouse. Taking the plot I showed you a moment ago, the Civic is way away from the prediction limits and the model that seems to describe all of the other points. If I wanted to see what would happen to the model if I removed the Civic, I could go ahead and click on it and then press the plus minus button on the toolbar. What that did was actually remove that Civic from the model and refit with all of the other data points. As you can see, we've added a lot of dynamic capabilities to version 16 of Statgraphics. I hope you'll give it a try and see how well they work on your data.